Hello everyone. So in this lecture, we'll be going through the definitions. Actually, we'll be using some keywords during the entire course, and we would like you to understand what are those keywords and what exactly we mean when we specify or mention them. So let me go through the one by one. So yes, first and the most common part is a multi-chain. So you might be thinking, okay, what is multi-chain? I heard about it somewhere. So it's an open platform. It's a software exactly where you can actually build your own blockchain applications, and it is actually an extension of the Bitcoin core. So it is a fork which is created through the Bitcoin core, and they have maintained the certain features of the Bitcoin which are very very powerful, and also given an extended certain features to add a more features into the Bitcoin core. So it became a very powerful platform where you can actually create your own blockchain application while remain aligned with the Bitcoin core. That's very important. So there are many extended features are available which are not available in the Bitcoin core. So it's a very important thing. And of course, being aligned with the Bitcoin core, it is very helpful for you to actually use the one knowledge at two places, in Bitcoin as well as in the multi-chain. So you don't have to learn the entire new thing again, because you are building something on multi-chain which will be used only at the multi-chain case. So it's not true. So you can learn something at Bitcoin and implement it here. Both things. So next is the blockchain. So if you want to understand what is blockchain in a very deep manner, so I have another course with the name of Blockchain Basics, a practical approach in the multiple platforms. So you can sign up that course, and then you can learn deep about the blockchain, how it works, what are the algorithm. But as in short, it's a decentralized database which stores information in the form of transactions. It can be public or it can be private, right? It stores data in an immutable form. How immutable, we'll talk about it later on. But immutable means it's not very easy to change the data, and it's very very easy to catch if something has been changed. So that's how it became immutable. And also it is highly secure because it's a decentralized and there are many parties involved to make the transactions. It's not very easy to fake a transaction and or do any malicious activity. It also, the data, whenever you store something using this into this blockchain, it generally gets stored using the consensus algorithms. Also, if there is a conflict, it is actually resolved using the consensus based algorithm. So it is safe again in that case. It also uses cryptography very heavily to record and sign the transactions. It also exists mostly either on a decentralized network or a peer-to-peer network. And so here is our definition. So let's summarize everything. So blockchain is a consensus based secure decentralized public database which stores information immutably over peer-to-peer network. Remember, I'm using the word database, but some people also use the word like ledger, public ledger, decentralized ledger, distributed ledger. So all are the same thing, because ledger is nothing but a collection of transactions. So again, collection of transaction, if we are talk about the database also, it is also a database, right? Because where everything is stored. So that's about the blockchain. So, and the next is the Bitcoin. So Bitcoin, you might be aware, it's a cryptocurrency. It's one of the largest cryptocurrency right now, built on top of blockchain technology. Remember, this is the most common question that people ask, that what is the difference between blockchain and Bitcoin. So Bitcoin is a product which is built on top of the blockchain technology. Similarly, you can create your own coin. Suppose your name is Toshendra Sharma, so you say TK coin or whatever. So, but to issue your coins, you have to use the blockchain technology. That's very important. Also, that Bitcoin removes the dependency on the trusted third party to execute the transaction. So that's the idea of the decentralization, to remove the dependency over the centralized trusted party to execute certain transactions. So Bitcoin actually have this feature. Of course, every blockchain has this feature, but Bitcoin actually uses it very aggressively. Transaction get executed by the peers based on the consensus based algorithms and recorded in the blocks by the miners. So this is a logic. The miners actually are the people or the node or the computer software which actually add the blocks into the blockchain. So transactions are being actually recorded by the miners into the block using the consensus based algorithms. Bitcoin also allows you to execute the transactions without trusting the receiving party. So that's the decentralizer, or removing the risk factor into the currency while transferring the money from one place to another place. That's the beauty of this Bitcoin. And yes, there can be even a cross-border transaction can be executed in seconds. But to convert the fiat currency into the blockchain or the cryptocurrency, you have to use some exchange to convert into that and then use it, right? So here's the definition. Bitcoin is a decentralized virtual cryptocurrency built on top of blockchain. Remember, it's built on top of blockchain. Something like Google is built on top of internet. Facebook has been built on top of internet. So Facebook is not internet and Google is not internet. So you can build anything on top of it. So whatever you choose, it's your call. So next is the hashes. So hashes for the computer science students very might be easy. That hashes is nothing but a digest or the crunched data. So let's say if you have a PDF or if you have a 1 GB file, or if you have video, or if you have a one string and you want to convert it into a unique fixed length of a string, then you will use the algorithm called hash algorithms. There are multiple algorithms like SHA-1, SHA-256, RIP-EMD. So these are the algorithms, and one most common algorithm is the MD5, which is now broken, considered broken because of the small size. So and in security, it is generally not suggested to use the MD5. So Bitcoin and the other this multi-chain kind of solutions, actually they use the double SHA-256 algorithms to ensure the better security and better guarantee for no collision. Collision means when two different data sets has the same string or digest or hashes. It is highly difficult and very very unlikely that this will happen. There are one in the trillions of chances that this can happen, but yes, it is practically possible, but the chances are very less. In Bitcoin, hash is computed twice. As I mentioned, that Bitcoin, the hash is computed twice, and most of the time it is a SHA-256. RIP EMD 160 is used for the wallet address. When they create the wallet address, they actually first perform the SHA-256 and then perform the RIP EMD 160 to convert into a small size wallet address. So when I say hashes or digest, it means any size of data and convert it into a fixed length of a string. And remember, this process is not reversible. So if you have a short string, you cannot regenerate the old data. So it's a one-way algorithm. You convert everything into a small form and that's it. You cannot go back. So, and also the beauty in this algorithm is, even if you change a one single bit, right, a one single bit in the data, the entire string will change. The chances that string will change only at a one letter, it is not possible. The entire string will change completely, and you can easily distinguish that data using which the hash has been generated has been changed. So the entire cryptocurrency has been built actually based on this logic, that it is not reversible and even a single bit can change the entire string. So that's the idea of hashes. So here in this example, if you can see, the hello string, right, is being converted into this fixed length string, and then the second round of SHA, this string has been converted, this bigger string has been converted into this string. So this is called double SHA, right? So that's how this works. Next is the Merkle tree. So in a block, there is something called Merkle root, and the signature of the Merkle root has been actually specified to ensure that no one has changed even a single bit in the any of the transaction, not just a one transaction. So it's nothing but a binary tree of the hashes. In Bitcoin, it uses a double SHA-256 hashes to calculate the root. So how it works exactly is, I'll just show you using the pen. So let's take this example only. So I'll just open this new. So let's say if you have 5 nodes, let's say one, right, and then you have two, and you have three, and you have four, and you have five, right? So in this, you will use these 2 nodes to generate the double SHA, and then you will use these 2 nodes to generate the another double SHA of this algorithm. And since it is a last odd node, you cannot do it. Then what you will do is you'll replicate this same, right, and then try to then generate the SHA of this. Then again the SHA of this will be generated, these two will be generated, right? So it will be again double SHA of these two data, and this again will be generated using this data, and also it will be using this data, because this will be replicated again, right? And then for ultimately you will have a Merkle root, which will be the digest of these two nodes. So this will be called, we call it a Merkle root, right? So remember, when we talk about a double SHA, so it means the SHA-256 of a data, and then you take the another SHA-256 of the output of the previous SHA-256. That's called a double hash, right? So in this you can see that D1, D2, D3 and D4 are being created using the double hash of the A, double hash of B, double hash of C, right? And then D1, D2 are concatenated with each other to create the another hash, and then similarly this has been created to create another hash. So this is how you will ultimately create the Merkle root and put it on the top. So this Merkle root actually generally being specified into the block, right? Because to ensure that nothing has been changed, it's very easy. So if any of the transaction has been changed, then you can calculate the Merkle root again, and if the Merkle root do not match, it means the block has been corrupted. Next is the mining. So mining is the process of adding a block into the blockchain. So of course this is also one way to make some money or to get some virtual currency. So there are many ways to get the virtual currency. Simplest way is to buy using the fiat currency, go to an exchange and pay some dollars and then get your Bitcoin. Another way is to earn through the mining by investing a computational power into the blockchain. So if you say, okay, so I'll be adding a block into the blockchain, I'll be getting 25 Bitcoin for adding a block. So okay, so 25 Bitcoin is a heavy amount, right? It's around $18,000 currently. So how much you have to actually invest, and what you exactly do using the computers? So the answer is that miners are actually asked to solve a very complex computational problem to identify that next block in the blockchain. Identify a new block in the blockchain is not very easy in case of Bitcoin, right? It depends on the algorithms to algorithm, of course, on also on the difficulty level and other many factors. So of course, to add a block, you will be rewarded with some Bitcoins or Ethereum or whatever cryptocurrency you are mining. And so what exactly the computational, power, and what is exactly the complex computational problem we are talking about? So talking about a nonce, we have to identify a random number in such a way that after merging it with the recent block, it should create a signature which is less than the previous block. So that's the idea, and in technically it's actually a long process to calculate and identify the right number, and you have to hit and trial completely many times before you identify the right one. And once you identify the right one, you announce it to everyone, hey guys, I identified a block. And if your block is accepted before someone else does, you'll get a reward. So that's the idea. So mining is the process of recording the transaction as a block into the blockchain for that currency. Consensus algorithms. So consensus algorithms are nothing but a method to resolve the conflicts. So of course, when you talk about a decentralized structure, people might have conflicts, right? So you need to figure out how to resolve the conflicts so that everything runs and executed smoothly. And also before you record a transaction, you need to make sure that it is valid by actually taking consensus from the network. So that's kind of algorithms are required. So it's a computational methodology to resolve conflicts in the blockchain whenever the conflicts happen. So what is decentralized? You might have heard about decentralized many times. So this is centralized. Second one is a decentralized, and third one is a distributed. So this is very clearly that decentralized means having a centralized nature, but in a distributed way. So it's called decentralized. So peer-to-peer and the server-based architecture are simply in server-based. There is a one server which serves the clients, and clients do not interact with each other directly. They first talk to the server, and server will communicate to the other client. But in the peer-to-peer network, every client is connected to other client, and there is no server. So that's called a peer-to-peer network or a mesh network. That's it. That's it for this lecture. If you have any query, please ask. Thank you.